Hello everyone, welcome to Ejeogbakonnect, and in this video we are going to be tackling a very important JAMB chemistry topic. Questions that always come out from this particular topic, because JAMB love this topic a lot and they like twisting this topic in between their questions. So we are going to be solving 15 specific questions just from this topic. And if you are just coming across my channel for the very first time, my name is Basi Ejeogba, and in my channel I help students level up their academic game. So if you love content like this, please don't forget to hit on the red subscribe button so you can continue getting updates anytime I drop helpful videos like this, and in turn you will help me grow. So right about time, we are going to be hitting on with the very first topic here on the board, which is a small quantity of NH4Cl. NH4Cl is what? Ammonium chloride. So a small quantity of ammonium chloride was heated gently in a test tube. The solid gradually disappeared to produce a mixture of two gases. Later, a white cloudy deposit was observed on the cooler part of the test tube. The sodium chloride is said to have the ammonium chloride is said to have undergone now they say a small quantity of ammonium chloride was heated gently in a test tube. This is what a JAMB question. So this is the option. It says A, distillation. Now what kind of separation has this, or what kind of nature of matter, you understand, the state of matter has this ammonium chloride undergone? That is what they're asking you. They want to ask about the state of matter, which we have three states of matter. We have the solid state, we have the liquid state, and we have the gaseous state, right? So they say the the ammonium chloride is said to have undergone A, distillation, B, sublimation, C, precipitation, D, evaporation, and E, decomposition. The main thing you have to pay attention to, forget all the grammar you are seeing here. The main concept you are supposed to pay attention to is the solid and two gases. The solid gradually disappeared to produce a mixture of two gases. When a solid changes to gaseous state, what has happened? That is basically what they are asking you. What is the change of state of matter that has happened there? That is what they are asking you. Forget about all this was observed on the cooler parts. All those words are to make the question lengthy. The Greek question is the solid gradually disappeared to produce a mixture of two gases. This solid is said to have undergone which change of state of matter? A, distillation, B, sublimation, C, precipitation, D, evaporation, and E, decomposition. It is not distillation, right? Distillation is used for the purification of two soluble solvents, right? So the answer is not distillation. The answer rather is B, which is sublimation. Sublimation is the correct answer. When a solid changes to a gaseous state, such a concept is known as sublimation. So the main answer here is sublimation. It is not precipitation, it is not evaporation, neither is it decomposition. I'm going to be making a video which we are going to be treating this change of state of matter. So make sure you also subscribe so that you get notified the moment I drop it. So let's move ahead to the next question, knowing fully well that when a solid changes to a gaseous state, that change of state of matter is known as sublimation. So let's move on to question number 2. The second question is, which of the following changes is not physical? A, adding ion fillings to aerated water. B, cooling water to obtain ice. C, adding sodium metal to water. And D, burning of domestic gas. Note that in chemistry we have basically two types of change. We have the physical change and the chemical change. Now, what is a physical change? A physical change is a type of change that is reversible and does not give the formation of a new substance. So when it comes to a physical change, it goes forward and it can also come backward, and no new substances are formed. And it is a clear opposite of a chemical change. In a chemical change, it is irreversible and new substances are formed. So that is basically the question they are asking. It says, which of these changes is not physical? Which of these changes is irreversible and can give birth to new substances? A, we have adding ion fillings to aerated water. When you add ion fillings to water, you can still get it back. B, cooling water to obtain ice. When you put your water in the fridge and it gives you ice, you can still allow it to melt and you still get your water. We have C, adding sodium metal to water, and D, burning of what domestic what gas. So the correct option here is option D, which is what the burning of what domestic what gas. When it comes to physical example of a chemical change is what burning, be it burning of domestic gas or be it burning of what wood, because at this point in time the wood cannot be gotten what back, so it is what irreversible, and new substances are formed, which is what the ash. Right, so you are going to get your ash, which is what a new substance, and the wood cannot be gotten back, which is what irreversible. So the correct answer here is what option what D, which is what the burning of what domestic gases. Question number 3 says, by means of filtration, one component cannot be obtained pure. Sorry, one component can be obtained pure from an aqueous mixture of sodium chloride, and by means of filtration, one component can be obtained pure from an aqueous mixture of sodium chloride and, right? So you have to take notes. So these are the options: potassium nitrate, B, sand, C, lead nitrite, D, sugar, which is what glucose, and E, which is what starch. Now the correct option there is what option B, which is what sand. Now why did I say it's option B, or why is option B correct? You have to take note of the what question. They say by means of filtration. So the separation technique number 1 there is what filtration. They're already telling you the separation technique can be gotten pure from an aqueous mixture. So this is another key point there. When you hear aqueous mixture, yeah, they're simply telling you that there's a presence of what water. So there's a presence of water in that what mixture. Aqueous mixture of what sodium chloride. So what they are simply telling you that this mixture involves sodium chloride, which is what common salt, table salt in what water. So when you mix sodium chloride in water, and which of these substance, you know that when you mix sodium chloride in water, it's going to totally what dissolve, right? It's going to totally what dissolve. So if you mix sodium chloride and water, and if you mix sodium chloride inside water and any of these substance, right, any of these components, which one can we get back pure? A, potassium nitrate, B, sand, C, lead nitrite, D, sugar, which is glucose, and E, which is what starch. The correct answer, like I say, is what B, because filtration here involves what the separation of what insoluble what solute from what solvent, insoluble what solute from what solvent. So at this particular point in time, the sand here is what a solute, the sand here is what solid. So sand cannot dissolve in what water. So at this point in time, just by using filtration, which is what the separation of what insoluble solutes from solvent, we can easily get back our what pure sand. So that is why the means of filtration, which can be gotten from aqueous mixture of sodium chloride and sand, is what filtration. So at this point in time, sand is the what correct answer. So let's move on to question number 4. Question number 4 says, one of the following techniques can be used to show that chlorophyll pigment is a mixture of what chemical compounds. We have A, crystallization, B, hydrolysis, C, sublimation, and D, chromatography. The correct answer there is what D, which is what chromatography. Now, what is what chromatography? Chromatography is a separation of mixtures. So one mixture will get one what spot. So the following techniques that can be used to show that this chlorophyll pigment is a mixture of different what chemical compounds is what chromatography. Now I want you to get this idea. The moment you hear chromatography, which is an example of separation technique, I want you to link chromatography to pigment. So when the moment you hear chromatography, the first thing that should come to your mind should be what? Pigments, should be pigment, should be colors, should be pigment, should be colors, should be ink, should be dyes, and also about what? Speed. So the moment you see any of these in a question, when you see pigment, when you see colors, when you see ink, when you see dyes, when you see speed, please, and when you see any of this in the question talking about separation technique, please just go ahead and start looking for what? Chromatography, because chromatography is going to be the correct what? Answer. So the following techniques can be used to show that chlorophyll pigment. The answer is what? Chromatography. Question number 5 says, which of the following compounds and elements will sublime on exposure to the what? Atmosphere? Which of the following compounds and elements will sublime on exposure to the what? Atmosphere? This is what an example of what? A change of state of what? Matter. And first of all, you have to know what is what? Sublimation. Sublimation is when a solid turns directly to what? Gas. When a solid turns directly to what? Gas. So we have here A, ice, B, sulfur, C, phosphorus, and D, iodine. The correct answer there is what? Iodine. The correct answer there is what? Iodine. Iodine is one of the elements that turns directly to what? Gas. Iodine is a solid and it's one of the elements that turns directly to what? Gas. Another compound that turns directly to gas on exposure is what? Ammonium what? Chloride. So next time, the moment you hear sublimation and they're asking you about an element or a compound that will turn directly to a gas, you have to know about what? Iodine. So for iodine, it is simply iodine what? Solid turning to what? Iodine what? Gas. Right? Iodine solid turning directly to what? Iodine gas. So the next time we hear of a compound that turns directly to gas is going to be what? Iodine. And a compound that turns directly to gaseous state is what? Ammonium. So ammonium what? Chloride. So these are the two compounds that are, or the two elements, and the element and the compound that is linked to the concept of what? Sublimation. Question number 6. It says sodium chloride may be obtained from brine by A. Titration, B. Decantation, C. Distillation, and D. Evaporation. Sodium chloride may be obtained from what? Brine. That's a brine solution by A. Titration, B. Decantation, C. Distillation, and D. Evaporation. The correct answer here is what? D, which is what? Evaporation. Now the first question you're supposed to ask yourself is, what is what? A brine what? Solution. A brine solution is simply a solution of what? Sodium chloride plus what? Water. So a mixture of what? Sodium chloride inside water is what is known as what? A brine what? Solution. So how can we get our salt from what? Water, right? Our salt that is what? A solute that is what? Easily what? Dissolve in what? Water, which is what? A solvent. You have A. Titration, B. Decantation. It cannot be what? Decant, right? It cannot be what? Distill. It is not distillation. Rather, it is what? Evaporation. Evaporation is what? Heating to what? Dryness. So you heat your water to dryness in order for you to get back your what? Salt. So the correct answer there is what? D, which is what? Evaporation. Question number 7, it says, which of the following is what? A mixture. Which of the following is what? A mixture. We have A. Granulated sugar. B. We have seawater. C. We have what? Sodium what? Chloride. And D. We have what? Ions fillings. Which of the following is what? A mixture. A. Granulated sugar. Forget about the word granulated. Don't talk about what? Sugar. B. Seawater. C. Sodium chloride. And D. Ion fillings. Forget about the fillings in the word ion. Ion is simply what? An element. So forget about the word fillings they want to use to what? Confuse you. So the correct answer here is what? Sea water. Sea water is basically what? An heterogeneous what? A mixture. Seawater is what? A mixture, because it contains what? Different what? Substances in the what? Water, right? Dirt, different things, shoes, dirty things, plastics in the water. So a seawater is example of what? A mixture, and also sodium chloride, ion fillings, and granulated what? Sugar. The next question is question number 8. It says, which of the following is an example of what? A chemical what? Change. Which of the following is an example of what? Chemical change? You have A. Dissolution of salt in water. B. Rusting of iron. C. Melting of ice. And D. Separation using what? Distillation. Which of the following is an example of chemical change? Remember, I taught you in the beginning of this video when I started talking about what chemical change, new substances are formed and it is what? Irreversible. So dissolution of salt in water, when we dissolve our salt in water, we can get it by heating the water to what? Dryness, evaporation. Rusting of iron. Rusting of what? Iron is what? Example of what? A chemical what? Change, because a new substance is what? Form. Rust, right? When you expose what? Iron to what? Moisture, that is what? Air and water, is going to be what? Is going to what? Rust. And when it rust, it turns to get what? Brittle, and it cannot get back their what? Iron again. So a new substance is formed, which is what? Rust iron, right? And it is what? Irreversible. We have C. Melting of what? Ice. When you melt your ice, we can see what? Get it to be what? Freeze, because you can still put it back in the freezer and you get it what? To be what? Freeze. Separation using what? Distillation. Separation using distillation does not mean it's going to give what? A new what? Substance. Basically, what we are talking about is what? Distillation. What we are talking about is what? Separation. So that one does not mean it's going to give us what? A new substance. So the following example there, which is a chemical change, is what? The rusting of what? Iron. And iron is rust when you expose it to what? Moisture, which is simply what? Air and what? Water over a long period of what? Time. If you are enjoying this class, please, I want you to take a pause. Look down, you see a like button. Click on that like button and also check, you are going to see a red subscribe button. So help me click on that red subscribe button and also share these videos to your friends so that they can come here and get value. So right ahead, let's move on to question number 9. Question number 9 says the presence of an impurity in a substance will cause the melting point to the presence of an impurity in a substance will cause the melting point to A, be stable, B, be zero, C, reduce, and D, what? Increase. The presence of impurity in a substance will cause the melting point of a substance to what? Reduce. Impurities increases the what? Boiling point and reduces the what? Melting point. Please take note. Impurities increases the boiling point of a substance and what? Reduces the what? Melting what? Point. So the presence of impurity in a substance will what? Cause the melting point to what? Reduce. Question number 10, it says the process whereby a gaseous body loses some of its kinetic energy to a colder body is the process whereby a gaseous body lost some of its what? Kinetic what? Energy to a cold body is A, condensation, B, melting, C, evaporation, and D, what? Freezing. The correct answer here is what? Condensation. They loses what? Some of its what? Kinetic what? Energy, and they tend to what? Fall down. Condensation. And it doesn't just fall down, what? Kinetic energy to a colder what? Body. Condensation. So the process whereby a gaseous body loses some of its kinetic energy to a colder body is what? Condensation. Number 11 says the property used in the industrial preparation of what? Nitrogen and oxygen from the air is the property that is used in the industrial preparation of nitrogen and oxygen from air. You know that the air is composed of what? Nitrogen, air is composed of what? Oxygen, air is composed of what? The noble gases, and it's also composed of what? Carbon dioxide. So air is what? A mixture of these various what? Element or compounds, right? So it's the property used in the industrial preparation of what? This what? Nitrogen and what? Oxygen from air. What they are simply trying to ask you is that how can we separate what? Nitrogen and oxygen from what? Air, right? So we have A, rate of diffusion, B, solubility, C, density, and D, boiling point. The correct answer here is what? Boiling what? Point. The industrial preparation of nitrogen from air involves what? Fractional what? Distillation, which is based on their what? Boiling point. So whether they put the separation of what? The industrial preparation of what? Nitrogen and what? Oxygen from air, it is based on their what? Boiling point, which is what? Fractional what? Distillation. So take note of what? That. Question number 12, it says a heterogeneous mixture can be defined as any mixture. Heterogeneous what? Mixture can be defined as any mixture A, whose composition is uniform, B, whose composition is not uniform, C, formed by solid and liquid, and D, of a solute and a solvent. The correct answer there is what? B, whose composition is not what? Uniform. We have two types of what? Mixture. We have the what? Homogeneous mixtures. We have the homogeneous mixtures, and we have the what? Heterogeneous what? Mixture. When we say homogeneous, this means that they are what? In uniform. You understand? They are uniform. That means they are mixed together. So they are what? Mixed. You cannot easily what? Separate. You cannot what? Separate them. You cannot say this one is this one is this. They are what? Mixed. And we have what? Heterogeneous, which means each of the what? Mixture is what? Separate. You can easily what? Separate them. Right? So it says heterogeneous mixture can be defined as any mixture whose composition is uniform. This mixture is not what? Uniform. Heterogeneous mixtures are not what? Uniform. We have whose composition is not uniform. C, formed by solid and liquid, and D, of a solute and what? A solvent. The correct answer is what? Whose composition is not what? Uniform. Question number 13, it says a mixture of petrol and water can be separated through. A mixture of petrol and water can be separated through A, the use of filter paper, B, centrifugation, C, separating funnel, and D, distillation. the use of what? The separation of what? Petrol and water. You find out that when you mix petrol and water, they cannot what? Dissolve. So these two substances are immiscible, and they are immiscible and what? Divergent. That means they are different from what? Each other. So a mixture of petrol and water can only be separated using what? Separating what? Funnel. That is how we can be able to separate what? Petrol and what? Water. So we don't use what? Filter paper, neither do we use what? Centrifugation, or neither do we use what? Distillation. What we use is the what? Separating what? Funnel. So the next question we have here is question number 14. It says sugar is separated from its impurities by A. Distillation, B. Evaporation, C. Precipitation, and D. Crystallization. The correct answer there is what? D, which is what? Crystallization. Crystallization is a means of separation technique used in industries to completely separate sugars from any form of impurities. You understand? So crystallization is used to separate sugar from its impurities, and not distillation, evaporation, and what? Precipitation. And number 15, which is the last on this particular topic, is which of the following is a mixture? Which of the following is a mixture? We have A. Blood, B. Sand, C. Washing soda, and D. Common what? Salt. And D. Common what? Salt. The first thing you have to ask ourselves is, what is what? A mixture, what is what? A compound, and what is also what? An element. Looking at this answer, the correct option there is what? Blood. Blood is what? A mixture. So blood is what? A mixture, and not what? Sand. How do we know that blood is what? A mixture? It is because blood cannot be represented by what? A chemical what? Formula. When a mixture, a group of, when mixtures coming together cannot be, when elements or substances coming together cannot be represented by a chemical compound, it is known as what? A mixture. Blood cannot be represented by what? A chemical formula, but sand can be represented by a chemical formula. Soda can be represented by a chemical formula, and common salt, which is sodium chloride, can be represented using what? A chemical what? Formula. So which of the following is a mixture? The correct option there on the board is what? Blood. So I would like to call it a wrap based on this particular topic, which is nature of matter and separation technique. We have lots and lots of questions that are based on this particular topic. So it's not just these 15 questions that I have done here. And if you are interested to get our past questions and answers based on topic by topic, be it chemistry, be it biology, physics, English language, or any subject that you'll be writing in your JAMB, drop it in the comment section. I will drop my WhatsApp number, chat me on WhatsApp, and you will be able to get these past questions and answer. If you are writing JAMB, if you are writing WAEC, GC, NECO, and you want to ace it in your one sitting, drop it in the comment section. I will share my WhatsApp number with you. Chat me up on WhatsApp, and you will get to register in our private WhatsApp group. We have various tutors who are going to take you on any subject, be it even arts courses. We have tutors who are going to take you on the subject, and we are not just going to take you on the subjects, we are also going to provide you with study materials, past questions, and a lot more. If you love this video, please don't forget to hit on the red subscribe button, and also share these videos to your friends so that they can come here and get value, and in turn I'll feel motivated to continue dropping videos like this. And until I see you in my next video, always remember that you are wonderful, always remember that you are unique, and always remember that you're a pace setter. I really love you. Thank you.